Lesson 15, Slopes of Lines in the Coordinate Plane. Your objectives are to find the slope of a line, use the slopes to identify parallel and perpendicular lines, graph lines and write their equations in slope-intercept and point-slope form, classify lines as parallel, intersecting, or coinciding. Your vocabulary words: arise, run, slope, point-slope form, and slope-intercept form. The slope of a line in a coordinate plane is a number that describes the steepness of the line. Any 2 points on a line can be used to determine the slope. The rise is the difference in y values of 2 points on a line, or the change in y. You can remember which direction is rise because the y-axis goes up and down. So you would rise up. The run is the difference in x values of 2 points on a line, or the change in x. Remember run because if you look at the x-axis, you could run across the x. The slope is the ratio of rise to run. If x1 and xy and you have x2 and y2 are any points on a line, the slope is y2 minus y1 over x2 minus x1. If you'll recall, I told you, do you see the 2 wine glasses on top of the picnic table? You have to be 21 before you can touch those. That will help you remember the equation for finding slope. So let's find slope. Use the slope formula to determine the slope of each line. We're looking at AB. We have a point at -2, and this would be +7, right? 5, 6, 7, and at 3, 7 for B. We substitute the -2, 7 for x1, y1, and 3, 7 for x2, y2 in the slope formula, and then we'll simplify like this. Since 7 minus 7 is 0, our slope is 0. This would make sense because the line is horizontal. The slope or steepness never changes. Let's look at AC. So that would be this line slanting down. We have the point again, -2, 7, and we have 4, 2. We substitute in the -2, 7 for x1, y1, and 4, 2 for x2, y2, like this. Our slope is -5, 6. This makes sense because our line is going down. If we had a little person walking across this line, he would be going downhill. Let's look at the slope of line AD. That's this one. We have the point -2, 7 and -2, 1. We substitute these points into the slope formula, and we're going to get -6 over 0. We are not allowed to divide by 0, so this slope is undefined. This makes sense because x never changes. For every y on this line, x is always the same, -2. Remember, a fraction with 0 in the denominator is undefined because it is impossible to divide by 0. We wouldn't want to go to algebra jail. So let's look at a summary of slopes. Positive slope, you would walk from left to right, goes uphill. Negative slope, walking left to right, goes downhill. 0 slope, no change in y, it's horizontal. Undefined, there's no change in x, and it would be a vertical line. One interpretation of slope is the rate of change. If y were to represent the miles traveled and x represent the time in hours, The slopes would give the rate of change in miles per hour. A transportation example. Justin is driving from home to his college dormitory. At 4 p.m. he is 260 miles from home. At 7 p.m. he is 455 miles from home. Graph the line that represents his distance from home at a given time. Well, we would use time and distance. So time would be our x and our distance would be our y, like this. You see at 4 p.m. he's 260 miles away. At 7 p.m. he's 455 miles away. So let's interpret the slope of the line. If we use those points, 4, 260, and 7, 455, we have that his slope, the rate of change is 65. He is traveling at an average of 65 miles per hour. And we hope that's below the speed limit. Here's some more theorems for your list. Slope of parallel and perpendicular lines theorems. 351 is the parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. The perpendicular lines theorem says in a coordinate plane, any two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are perpendicular. So if we want to do an exercise recognizing parallel and perpendicular slopes, if a line has a slope of AB, the slope of the perpendicular line is -b over A. If we were to multiply these two fractions together, we would get -1. The ratios AB and -BA are called opposite reciprocals. Let's keep in mind, just because we're given 4 points, it doesn't mean they always determine two lines. Graph the lines to make sure the points are not collinear. They might all be on the same line. Let's determine whether lines are parallel, perpendicular, or neither. Graph each pair of lines, use their slopes to determine whether they are parallel, perpendicular, or neither. We're given lines UV and XY. U is at the point 0, 2. V is at -1, -1. X is found at 3, 1. And Y is at -3, 3. So if we look at this and we graph those points, we do have lines that intersect. Now we have to figure out their slopes. The slope of UV is -1 minus 2, which is -3, over -1 minus 0, which is -1. So our slope is 3. UV, it's a very steep line. And we can also see this by counting from V up. 1, 2, 3, and over 1. So our rise over run would give us +3. We're going uphill. The slope of XY, well, let's look at this. We would go down 2 and over 1, 2, 3, 4, 5, 6. Down 2 over 6 is the same as -1/3. The products of the slopes are -1. The lines are perpendicular. We also, without multiplying them, can see that 3 over 1, positive, and negative 1 over 3 are opposite reciprocals. Let's do this again with a different pair. We have GH and IJ. We've graphed these lines, G at -3, -2, H is at 1, 2, I is at -2, 4, J is at 2, -4. We have a positive slope for GH just by looking at the line, and we can see that IJ has a negative slope, and we intersect right here. We don't know exactly what that point is. So let's use our slope formulas. For G, we go 1, 2, 3, 4 up, and 1, 2, 3, 4 over. 4 over 4 is going to give us a slope of 1. For IJ, we count 1, 2, 3, 4, 5, 6, 7, 8 down, and 1, 2, 3, 4 over. 8 divided by 4 gives us a -2 because we had to count down by 8. 1 and -2 are not opposite reciprocals. The lines are not parallel because they cross, so this would be neither. Let's look at one more set. When we graph these two lines, where C is -1, -3, D is at 1, 1, E is at -1, 1, and F is at 0, 3. They look parallel. Do they have the same slope? The slope of CD, 1, 2, 3, 4 up, and 1, 2 over, is the same as 2. And for the other one, we have 2 up, 1 over, so it's 2. These lines are parallel. They have the same slope and a different y-intercept. When we say y-intercept, we mean where it crosses the y-axis. The equation of a line can be written in many different forms. The point slope and slope-intercept forms of a line are equivalent. Because the slope of a vertical line is undefined, these forms cannot be used to write the equation of a vertical line. The point slope form looks like y minus y1 equals m times x minus x1. M is the slope and x1, y1 is the given point on the line. For example, if we are given that m equals 2 and x1 and y1 is 3, 4, we simply plug in the 3 and 4 in place of x1 and y1 and put the 2 in place of m. The slope-intercept form is our most commonly used for graphing. So we want it to be y equals mx plus b. Remember that b stands for beginning. When we graph, we start at b. In this case, it's 6. Then we use the slope for movement, how our line moves. So we would go up 3 over 1. The equation of a vertical line will not have any y's in it. Since a vertical line has an unchanging x, then we simply have whatever x equals, and that is the equation of the line. It is the x-intercept. For every y, x equals 5 in this example. A horizontal line has no change in y, so it means that for every x, y will be the same. So we simply write y equals b. That is where it intercepts the y-axis. So in this case, it would be y equals 2. For every x on the line, y equals 2. Don't forget, a line with y-intercept B contains the point 0B, and the line with x-intercept A contains the point A0. Let's write the equation of each line in the given form. We want the line with the slope 6 that runs through 3, -4 in point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. So we plug in our values that we know. We have -4 for y1, 6 for slope, and 3 for x1. We can simplify a bit and have y plus 4 equals 6 times x minus 3, but we can leave it with a double negative. For example, for B, we want the line through the 2 points, -1, 0 and 1, 2 in slope-intercept form. We have to find the slope first, so we plug those in. y2 minus y1 gives me 2 on top. 1 minus -1 gives me the change in x, which is 2 on the bottom. So my slope is just 1. Find the slope. We want y equals mx plus b format. Slope-intercept form. So we have 0 equals 1 times -1 plus b. All we've done here is to substitute in our first point into this equation so that we can find a value for b. We want to know what the y-intercept is. This 0 tells us this is the x-intercept. So b equals 1. My equation is y equals x plus 1. Example 4c. Let's find the line with the x-intercept 3 and y-intercept -5 in point slope form. So we're given the intercepts. We need to find slope. X-intercept means 3, 0. Y-intercept means the point 0, -5. So we have -5 minus 0 and 0 minus 3. This gives us a positive slope of 5/3. Then we substitute the points in. We have y minus 0 equals 5/3 times x minus 3. So y equals 5/3 times x minus 3. To graph these lines, remember we said we start with b, the beginning, and we use the slope. So we start with 1, and we rise 1 and run by 2. The equation is given in the slope-intercept form, a slope of 1/2 and a y-intercept of 1. Plot the point 0, 1, and then rise 1 and run 2 to find another point. Draw the line containing the points, and you're finished. Let's try another one. You'll see this is in point slope format, so we have to solve this so that we can graph it. The equation is given in the point slope form. We have a slope of -2 through the point 4, -3. We plot that point for -3, and then we rise -2, in other words, we go down by 2, and run over once to find another point. And then we can draw our line. We have y equals -3. Remember, this means that on this line, for every x, y equals -3. This is a horizontal line. We simply draw our y-intercept at -3 and make a line through there horizontally. A system of two linear equations and two variables represents two lines. I'm given two equations. I have two lines. The lines can be parallel, intersecting, or coinciding. Lines that coincide are the same line, but the equations may be written in different forms. For example, maybe I multiplied the line by 2 and wrote it again. So it looks like double the first line, but it's really the same. Parallel lines have the same slope, but a different y-intercept. So the slope is the same, the y-intercept is different. Otherwise, it would be the same line. Intersecting lines have different slopes. Coinciding lines, they are the same slope, same y-intercept, same line. Let's determine if the lines are parallel, intersect, or coincide. On top, we have two lines, y equals 3x plus 7, and y equals -3x minus 4. Well, let's just look at that. We have 3x and -3x. The number's the same, but one is positive, one is negative. So these lines intersect. For B, y equals -1/3 x plus 5 and 6y equals -2x plus 12. The first thing we need to do is solve the second equation for y to find the slope-intercept form. They need to be both y equals something. So we would divide by 6, and this gives us y equals -1/3 x plus 2. Oh, they both have the same slope, but different y-intercepts. These lines are parallel. Let's look at one more example. Determine whether the lines are parallel, intersect, or coincide. We have 2y minus 4x equals 16, and y minus 10 equals 2 times x minus 1. Neither of these are in y-intercept form, so we're going to solve both equations for y. Let's start with the equation on the left. We add 4x to both sides and divide by 2. This gives us y equals 2x plus 8. For the other one, we add 10 to both sides. We multiply the 2, distributing it, and we get 2x plus 8. Oh, well, this is the same line, written in two different ways. So these lines coincide. They are the same line.